Hey class, hope everyone's doing all right. This is going to be an audio version for you to listen to me reading the article. But that being said, I'm trusting all of you to at least try to attempt to read it first on your own. That's why I posted just the article first. So if you I want you to try reading it first and then listen to me if that helps. Or some of you might find you don't need to listen to me at all. But I'm just going to read the article and you can follow along with me on the screen as I read it here. The title of this is Space Spinoffs. The technology to reach the moon was put to use back on Earth. This was published July last year, which was the 50th anniversary of the Apollo program. It was a pretty exciting time. That's when the new exhibit was at the Flight Museum down in Seattle. And I went and visited that in the summer, and you got to see the Apollo capsule. It was really cool. So last summer was the 50th anniversary. I will begin. The Apollo program was gigantic. The US government spent roughly 26 billion, about 260 billion in today's dollars according to one estimate, between 1960 and 1972 to hire contractors and subcontractors who employed hundreds of thousands of people to create and improve on technology that led us to the moon and back. While some of that tech has stayed within the space industry, a lot of it has trickled down to the public. There's a huge list of the stuff, and NASA has an entire department dedicated to cataloging it all. Sometimes separating the myth from reality isn't easy. These 6, however, are bona fide space program spin-offs. And you'll see the cool animation here going from the Apollo program version to what could be used today. And so you might see these kind of interesting shrimp looking things in a plastic bag. And you can see the spacecraft instruments, and then it goes to looks like a camping scene. So let's find out what that is. Freeze dried food. Beef pot roast, lobster bisque, peach ambrosia, all things that, if you were an Apollo astronaut, you might be eating out of a plastic pouch while speeding away from Earth at 5,000 miles per hour. Freeze-dried foods were perfect for the weight-conscious Apollo missions, in which the spacecraft needed to stay lean enough to get to the moon and back, even as the astronauts consumed a hearty 2,800 calories per day to keep themselves going. A favorite, shrimp cocktail, according to Charles Borland, a food scientist who started working on the Apollo program in 1969. It's got a little bit of spice to it. The shrimp hydrates really well. It's just like having a fresh shrimp cocktail with cocktail sauce, he says. One thing they had to avoid: high fiber diets. On the Apollo missions, the system for defecation was little more than a bag with a small opening and some adhesive around the edge. It was so inconvenient that could take astronauts 45 minutes to complete the process. And there was a chance that some of the waste material could escape and soil other parts of the cabin. Astronauts didn't want to have to go to the bathroom any more than they had to, Borland says. I always said that bathrooms in the spacecraft were the biggest improvement in the food system. Since Apollo, space toilets have gotten better. And we could start using regular food, he says. Freeze-dried foods weren't invented for Apollo specifically, but the number of varieties, their texture, flavor, and presentation all changed because of it. Fruit cocktails, for instance, had to be reformed so that they wouldn't be crushed when they were sealed in vacuum bags. Sorry to disappoint, but astronaut ice cream wasn't part of the space program. There they are eating. This looks like they're in the space station. So the caption here says astronaut James H. Newman and Michael Massimino wear a liquid cooling and ventilation garment that completes the spacesuit during a 2002 mission. Also pictured in the Columbia spacecraft shuttle are astronauts John M. Grunsfield. So Freeze-dried food is very lightweight, which is a big deal when you're sending people into space. You can't really use canned food because it's so heavy. Same thing when you're hiking or camping. You want your food to be light if you're carrying it on your backpack. And it preserved for a really long time. People use it for emergency foods as well. So this picture is probably for the cooling suits right here. Cooling suits. Spacesuits need to be completely sealed to protect astronauts from the ravages of the great unknown, which also means that they can get pretty stuffy. That's why NASA acquired the rights to these liquid cooling and ventilation garments in 1966. The skin-tight suits had 300 feet of tubing snaking along the outside and running chilled water across the skin, pulling heat away from the astronaut's body and helping them control their core temperature. 53 years after the design was made public, it's being used to help people with multiple sclerosis whose symptoms are exacerbated by heat. Heat for me is like kryptonite for Superman, says Josie Benassi from Reading, Massachusetts, who has multiple sclerosis and likes to go on long tandem bike rides with her husband. When temperatures rise above 75 degrees, her muscles weaken, and it can be tough for her to walk or even stand. A cooling vest attached to a cooler with a pump and a battery pack makes those rides possible. Without cooling gear, I'm good outside for 20 minutes, says Marco Martinez from Austin, Texas, who also has MS. I'm a prisoner from June until September in the house, unless I have some cooling equipment with me. The product Marco and Josie use is from Cool Shirt Systems, whose founder was inspired by NASA's design. Okay, we've got another animation there. So we have firefighter and a guy in a spacesuit and a spaceship. Fireproof materials. I believe this is our third invention so far. After 3 astronauts were killed in the Apollo 1 fire on January 27th, 1967, NASA was left scrambling to try to figure out how to make everything in the command module less flammable, including what the astronauts were wearing. The agency needed something that wouldn't melt or catch on fire and that could insulate astronauts from the intense heat of flames. It found what was needed was polybenzimidazole, I don't know how to say that, or PBI, a heat-resistant material developed by Dr. Carl Ship Marvel. Yes, Dr. Marvel, a pioneer in synthetic materials. After Apollo 1, the Kalanisi Corporation came up with a fiber that was woven into clothing beneath the puffy outer shell of the astronauts' spacesuits, providing another layer of protection, although it has since been phased out. Firefighting suits that contain PBI are the one main market for the material now. According to the manufacturer, it's effective for up to 1,300 degrees. A lot of people didn't realize that's where it came from. It started from Apollo, says Bill Lawson, president of PBI Performance Products, which was spun off by Kalanisi and sold to investors in 2005. Unfortunately, those 3 astronauts paid the ultimate price, but yet no one would have probably made PBI unless that happened. Okay, looks like we got a Jeep in the desert to the moon buggy on the moon here. Pretty cool. Spring tires. Driving on the moon is way more extreme than off-roading on Earth. Wild temperatures swing, and unfiltered sunlight will punish regular tires. Shards of dried lava will shred them, and there's 6 times less gravity, so if you hit a rock, it'll send you flying. What you need is a durable tire, stiff enough to support a vehicle, but squishy enough to roll right over rocks. Oh, and you can't have a flat. AAA won't come and get you. So, Apollo engineers outfitted the lunar roving vehicle with airless tires made of springy, woven steel wire that were much like a guitar or piano string. Those wires were on the rovers that flew with Apollo 15, 16, and 17 when they were forgotten for more than 30 years. Then they were forgotten for more than 30 years. But in 2004, President George W. Bush declared we were returning to the moon. As NASA got in gear, Vivek Asnani a young aerospace technologist at NASA's Glenn Research Center, became fascinated by the long-forgotten wheels. It was totally amazing that they came up with this. How do you think of something like this? So here's the pictures of the moon buggies, the later missions. Apollo 17 mission commander Eugene A. Cernan makes a short checkout of the lunar roving vehicle. During the early part of the Apollo 17 extravehicular activity at the Taurus Littrow landing site in 1972, you can see the details of the wire wheels right there. That's a pretty cool invention. That would be really fun to drive those around on the moon. In 2007, Asnani tracked down the original designers, one of whom pulled a spare Apollo tire out of his closet as a gift. With the Goodyear's help, Asnani's team built a dozen replicas, and by 2009, they had developed an even better version with chainmail-like appearance, which they called the spring tire. They were ready for the moon, and then President Barack Obama canceled the program. Since then, Asnani's team has swapped steel wire for nickel titanium, shape memory alloy, a better material with the superpower to deform and regain its shape. They've tested the tires on Jeeps, and Asnani says the idea could be used to make Earth tires never go flat. Oh, and now that our sights are once again on the moon, chances are we'll want those wheels when we get there. What do we see here? Might look familiar. Digital fly-by-wire. Kind of look like a calculator or computer. Neil Armstrong was an outstanding pilot who had the right stuff to get NASA to the moon. But even a pilot of his caliber couldn't single-handedly control the lunar module's 16 thrusters and 2 rocket engines. The job of flying a spacecraft is too mathematical for a human to do it by the seat of their pants. So, there really is a necessity to have a computer, says Don Iles, a computer scientist who worked on software for Apollo's lunar module. The Apollo spacecraft was a crucial demonstration of digital fly-by-wire technology instead of a manual system of pulleys, cables, and hydraulics attached to the pilot's control stick and pedals. In a digital fly-by-wire system, the pilot's controls feed into a computer, which uses software to process and translate those commands into electrical signals sent to the components that control the spacecraft's movement. It really created a kind of digital reality, says David Mendel, CEO of Humatics and author of Digital Apollo. The human is flying an idealized model of the machine, which is a simulation. And then the computer forces the machine to behave like that idealized model. Digital fly-by-wire technology has since helped steer the space shuttle, commercial jets such as the Boeing 777 and the Airbus 320, and a fleet of fighter jets and bombers. In fact, it was the F-8 Crusader jet that first used the technology, after NASA engineers proposed installing an analog fly-by-wire system in the plane in 1970. The deputy associated with administration for the aeronautics at NASA reportedly asked, "Why analog?" The engineers replied that they knew of no digital computer qualified for the flight. The administrator, who happened to be Armstrong himself, replied, "I just went to the moon and back on one." It looks like we have a 50-cent piece from planet Earth. This is 1.5-inch silicon disc left on the moon by the Apollo 11 astronauts bears messages of goodwill from many heads of state. The process used to make this wafer is the same that is used to manufacture integrated circuits for electronic equipment. Integrated circuits. The Apollo spacecraft required light, compact, powerful computers, so NASA and the MIT Instrumentation Lab made a daring decision. They built the Apollo Guidance Computer with a promising but relatively unproven technology, the integrated circuit, which packed multiple transistors into a single silicon strip. The Apollo program didn't invent the microchip, but it guaranteed a huge early market by 1963. Project Apollo absorbed up to 60% of the U.S. supply of chips. The military also installed chips in its Minuteman II missiles. So basically, we're talking about microchips here, which are used in computers and your smartphone and everything like that. Both NASA and the Air Force forced companies like Fairchild Semiconductor to prove the chip's reliability by subjecting them to extreme temperatures and G-forces and rigorous visual and electrical inspections. The result? Apollo helped in part to accelerate the silicon chip revolution at the pace predicted by Gordon Moore's famous law about the accelerating pace of computing power. You probably would still have integrated circuits, says John Tylko, a scholar who teaches a course called Engineering Apollo at MIT. You probably still would have had Moore's law, but you might not have had Moore's law in 1965. You might have had it a decade later. Telco says that astronauts Eugene Cernan, who left humankind's last footprints to date on the moon, may have summed up Apollo's achievements best in 2007 when he said, "It's almost as if President John F. Kennedy reached out into the 21st century where we are today, grabbed hold of a decade of time and slipped it neatly into the 60s and 70s and called it Apollo." All right, so there's your article. And you should have those 6 different inventions that we have to thank because of the Apollo program and why they were invented for the missions to the moon and what we use them for now. I realized this was a pretty high level reading article. Even I was messing up on some of the words there, but there's important stuff in there, and I hope my version of reading it helped you guys out. And if you're still confused, well, you get to rewind this and play it and pause it as much as you need. And if you're going through, you can easily see in bold right here each item as you go back to it. All right, guys. Good luck, and I'll see you next time.